I hope you are all safe in these tough times. Okay, so today I'm gonna present on setting up mTLS for gRPC client and server. So I have got gRPC server in Golang and gRPC client in Node.js. So yeah, let's start. Let's get started. Yeah, so a little bit about me. My name is Mahindra, and I work at InfraCloud Technology as senior software engineer. You can find me on GitHub at this link, github.com/Mahindra Babul. And as far as my interests are concerned, then I like distributed systems. So Kubernetes, Golang, and cloud native technologies are few of my favorite tools. Okay. Apart from Golang and Node.js, I also like Java a lot. Okay, because that's my first love, I would say. Okay. So this is a brief agenda for today's session. So the session is divided in two parts, theory and demo. So I will be covering few of the concept or like basics of gRPC and protobufs, and then we will also quickly talk about the different ways of gRPC services deployment, and also we will quickly have a look at Kubernetes and Ingress deployment because as part of one of my demo, we are gonna deploy the Golang gRPC server on top of Kubernetes, and we are gonna expose it through the Ingress so that my Node gRPC client running on my local host, right, or on my machine, local machine. So that is gonna be like a setup, and so that's why we need to touch on few things from Kubernetes and Ingress deployment also. And we will also like quickly talk about certificates and mTLS because I have like extensively used certificates to achieve the mTLS between the gRPC server and client. So we need to have some basic understanding, so we will cover few things in the theory part as well. And last, I will like I have a diagram where I have added all the components which are required for my gRPC server and client to run on top of Kubernetes. And then I will walk you through the code. So most of my presentation is the code is containing the code windows only, and I have got total 6 demos. Yeah, 6 of them. Okay. Yeah, so gRPC, right? So gRPC is high performance and open source universal RPC framework. Okay. So high performance, that means everybody should be using it, right? Because it has got really some best of the world things implemented. So few of the things like simple service definition. So whenever you are writing a server, that time you need to add some contract, or you need to define some contract, right? So that your clients can use or refer that contract to invoke your server methods, right? So the service definition is a very simple file, and it is called as a protobufs. Okay, so I will talk more about it in next slide. So you can basically start using gRPC quickly. You can start with the development environment, and then go on adding multiple services, and then you can basically also scale to millions of requests per minute, right? That much scalability can be achieved using gRPC. And also like this gRPC framework is available across the languages and across the platform, so it works very smoothly there as well. And bidirectional streaming, right? So earlier there was a protocol called WebSocket, and it was basically the standard for having the full duplex communication. But using gRPC, that has using gRPC, we have a new approach now to implement the bidirectional streaming. Okay, and it has also got few plug and play integrated authentication mechanisms in gRPC. So we just need to like plug them whenever we want to use. And yeah, so gRPC is a cloud native computing foundation project. Okay. Yeah. So what are protobufs? Protobufs are basically language neutral, platform neutral, extensible mechanism for serializing your structured data. So when you are using REST server, that time you define you have some JSON structure, right? You have JSON array, and under that JSON array you have some object, right? So similar to that, there is a something called protobufs in gRPC, and you basically define the ideal interface definition language like this. Okay, so the proto 2 is the syntax I'm using here in polyline.proto, and there are three messages basically which can be like interchanged between client and server. So point, line, and polyline. So in point, if you see in that message, three fields are there, two are required and one is optional, right? X. So any point is any point, right? It has two things, X and Y, right? And in line, if you see, the point has been embedded now. So whatever message was earlier, so that has been embedded in a line. Okay, so start and end basically, right? And also there is an optional one again. A few parameters can be optional like label, and then there is a polyline message. So polyline means the line can have multiple points, right? And the line can have multiple start and end as well. So that's why the points can be list. I mean, if you are defining the JSON, if you like resemble this with a JSON, then the list becomes repeated here, right? So this point, right, this will be repeated basically is a list. Okay, so list of points basically in a polyline. And again, there is an optional field in a polyline message. And again, I mean, in the same file you have services as well, and that service means basically it will have some methods which will be basically invoked by the clients, right? Yeah, so this is a little bit about protobufs. And so this is like a typical grpc communication will look like. So you have a service definition file. So earlier we the point line dot proto I showed you, right? So in my demos I have used employee dot proto. So employee is a message, right? So it has got id, first name, last name, and one other field. Okay, and again a few methods like get details, and that those details I have added to the .proto file. And again, so to implement this file, or like to have the server for serving the request of the clients, we need to like have a server component. It is called as grpc server, and in my demos I have it in a Golang. Okay, and that is basically called as the employee service. So for me, the project name is a Golang grpc server. Okay, and again employee search, which is another project. Okay, that is developed in node.js, but again that is a grpc client. So grpc server and grpc stuff, they are talking over the proto over http2. So whatever communication happens between client and server in grpc, that happens over http2, whereas in rest it also happens on http 1.1. I mean, it is quite now possible, and people are using http2 for rest services as well, but for grpc we need to have http2. It won't work on http 1.1. Okay, and yeah, so these are like few ways of deploying the grpc backend. Okay, so here you can see in the first diagram, first part of the diagram, so there I have got two grpc services. Okay, and then there is a rest api server. Okay, which is basically grpc client to these two grpc servers. Okay, so you can see here protocol buffers, that's the communication mechanism being used between REST API server and the gRPC servers, right? And then there is a browser client developed in JavaScript, like JavaScript framework like React or Angular, and that is calling the HTTP methods in the REST API server. Okay, and that's how your gRPC services are being used. So my experience is also in this one. Okay, so like a few services I have developed, and there we had them in the backend, and we had one more converter REST API server which used to take all the JavaScript web app request, and then the request were getting converted to the gRPC calls. Okay, so nowadays there is a one project booming in a market called gRPC web. So here you can see now in the browser itself the gRPC web app is run. Okay, and then communication from the browser to the backend, it happens over the protocol buffers. Okay, so there is no converter in between. Okay, so this is also like one another type of deployment of gRPC backend. And also the backend is a like a pretty broader term here, right? So your gRPC servers can run in containers, or can run on Kubernetes, or can run on plain VMs, right? Or your VMs can be like part of your virtual box setup on your local, or your VMs can be in the cloud as well. Okay, why I'm talking about this, because in few of my first demos, I have gRPC server and client running on my local. Okay, and in the last demo, I'm gonna like push my gRPC server to the Kubernetes setup. Okay, yeah, so any Kubernetes setup with Nginx Ingress will look like this. So Kubernetes is an orchestration tool for microservices, we can say, right? And your microservices are basically run in a container, and your containers are part of your pod, and then pods are basically grouped using services. Okay, so whenever the request comes from the external world, it first reaches to the Nginx Ingress or any Ingress you have configured. So there are many Ingress controllers available in the market. So for example, Contour or Ambassador is there, or Glue is there, right? So for my demo, I have used Nginx Ingress controller. Okay, so that basically just handles the lifecycle of Ingress, I can say. So Ingress is another Kubernetes object like service and pod and deployment. So whenever we want to like expose our grpc services or any other services to the external world, we need to take help of Ingress. Okay, and then we need to also have an Ingress controller. Okay, so in my demo, I have a Kubernetes cluster which is created using kind Kubernetes in Docker. Okay, and then I have installed Nginx Ingress controller on top of it. Okay, and then also I have got one Ingress which basically exposes my grpc server to the external world. So what I mean by that is my Node gRPC client is still like running on my local, but it will connect to the Golang gRPC server running on a Kubernetes cluster, and then that communication will happen through the mTLS. Okay, so you might have so now I'm introducing you the term called mTLS, right? So before that, I want to tell you a few things. So for example, whenever like you are exposing your server to the client, you need to have that whole communication secure, right? So most of the time we see there are server certificates. So for example, if you are accessing www.google.com, then the certificates are downloaded, right? And then again they are verified. So I have got few diagrams in the next slides where I can explain more on that part. Let's go to the next slide. So server certificates only, right? When this is there, then, and also like, I mean, there is always a question like, how does HTTP, for example, you have got any website with HTTPS, right? For example, HTTPS :// right? When you are accessing that website on your machine, right, local machine, then so this one point, right? So 1, 2, 3, 4, 5, 6. There are 6 steps, right? So user is accessing secure website, for example, www.facebook.com. Then the DNS records for that website or domain name are checked. Then IP address is retrieved, right? And then here website records found and going to the host web server now. And now when that happens, the browser also requests the secure SSL connection from the website host. So website host means the facebook.com server, right? And then that facebook.com server will basically send you the certificate, a valid one, right? If it is not valid, then you will see the red buttons. You might have seen that error. Is received by the browser, it checks that certificate whether it is signed by a public certificate authority or a, and if the browser founds that certificate as a valid, then it just establishes the connection with the remote server, that is facebook.com's uh, app server, right? Web server, we can say. And that's how, I mean, here you can see that only the certificates were involved at the server end only. So in mTLS, what happens is that client also needs to show their certificate. So here in this diagram, you can see we have already seen the server certificates flow, right? So here, if you see, client is first trying to connect to the protected resource on a server, right? And then that time what happens, server cert will be returned, right? So when the server cert is returned or accepted, is received by client, that time client will try to verify that certificate with the certificate authority, right? So certificate authority can be public or private as well. Okay, so here both client and server certificates, they are signed by the same certificate authority, right? Here you can see after the third step, the fourth step is present client certificate. So everything went well till this point, and now client is trying to presenting its own certificate called client.cert. Now server, what will it do is it will try to verify that certificate with the CA. Once once the server finds that this client cert is also valid, then a secure access will be granted to the client, and client will be able to access the protected resource. And that's how the mTLS works. So we are basically gonna achieve the same thing here. The grpc client will be this one, the grpc server is gonna be this one, and then we have also CA. Some intermediate CAs are also there. I will talk about it, what is that. in next slide. And then the communication is basically established. Okay, so moving on to the next slide. Yeah, so this is how the certificate hierarchy look like. Okay, so you can see that there is a root CA. Okay, that is basically a issuer 2, or I can say that is basically a signer for these two intermediate CAs, CA1 and CA2, right? And in my demo, I have client CA and server CA. They are basically intermediate CA. Okay, so this intermediate CA1, this is used to sign the certificate 1 and certificate 2, and CA2 is signing the certificate 3. So in my case, in my demo, I have server CA and client CA. Server CA signs server certificate and client CA signs client certificate. Okay, so how basically the signing of certificate works, right? Or how does CA sign the certificates? So basically, you have a certificate authority. You can have a self-signed certificate authority, or you can use some third-party public certificate authority as well. Okay, so there is applicant who wants to get its certificate signed by the CA. Okay, so applicant needs to add the identifying information to generate the CSR along with the public key of applicant. Okay, so user first needs to create private key and public key, and then with public key and some identifying information, a CSR file is created, and then that file is sent to the CA. What CA does is CA will first validate the identity, whether the applicant is really what he is saying, right? Then after that validation, what will happen is that CA will generate a signed certificate and send it to the applicant. But in that process, CA needs to sign that certificate with the private key of CA. Okay, so this is very important because I have got some commands in my demos, and it is important to understand this flow. Yeah, so now we are to the demo. Okay, so the first demo is about performing a basic unary operation between client and
Okay, so let's go to demo 1. So before that, let me introduce you to the repositories. Okay, so I have got 4 repositories in total for the final demo, but for the demo 1 we need just Golang grpc server and node grpc client. Okay, so I have opened them here. So I am currently in Golang grpc server, and I'm currently on first demo and second demo branch. I will tell you the reason behind merging the changes of two different branches in a single branch. Okay, so let us first get acquainted with the folder structure here. So we have got database, which has employees.json. It simply has the list of employees. Okay, then there is a protos folder. So as we saw, protos for employee.proto or whatever, for example message.proto, that file basically has all your messages and related operations on it, right? So we have already seen this kind of structure in the slides. So here employee request is another message which has id as attribute. Employee response, it basically has employee details as a response, and that is another message. So we have basically embedded employee details inside employee response. Okay, and then there is a service. So things like this, these are basically like the actual rpc calls. So here you can see get details is a rpc call. So whoever will be client to this server, okay, so that will basically be calling this get details method, and will be able to retrieve the employee by id, right? Now we will look at main.go. So main.go is a simple Golang code. Here you can see the port is 50051, which where the grpc server will be running on, and then the path for employees.json, that's basically acting as a database for us. And here you can see the actual implementation of get details. Okay, so the employee request struct is coming here, then we are retrieving id out of it, and then again just filtering uh, the employees by id, and then just returning the single employee object in the form of employee response, right? It's a helper method get employee details. If we go down below, again it's another helper method to get all the employee details, basically reading the json file and then putting it in a list, and then just returning that list here. And in main method, you can see here that the code is listening on port 500, which 50052, which we define to the top of the file. And here we are creating grpc new server. So this is how the grpc server is started in Golang. Okay, and here we need to basically register the employee proto as well. So you might have you might be wondering about this employee, some inbuilt or like by default available packages or and Golang constructs, right? So where are from where these are coming, right? So they are basically coming from this employee directory here, and you can see a few two files created here. And again, you can see code generated by protocgen.go dash go, right? So this code is basically employee pb.go and employee underscore grpc.pb.go. These two files are basically created using uh, a file uh, using a command called proto c. Okay, that's what I'm going to show you. So if I open uh, this my a little folder here, it will have the exact file. Okay, so this is the command which if you fire it in the project where the .proto file is residing, then it will basically create the .go files for that particular proto file. Okay, so this is the command which I have fired on my grpc server root directory. Okay, and then it has created these two files. Okay, so this is like pretty much about it from the first demo. Okay, uh, let us now run the server main.go. Okay, and now we are going towards node grpc client. Okay, here also I'm on first demo and second demo branch. Okay, and here if you see the directory structure, I have got a client a folder, then protos folder again, right? It also should have the same proto file because this is the contract between server and client, right? And in index.js, let us see what is there. So it so index.js basically is having references for grpc-js. We are like uh, importing a grpc JavaScript object here, and then again using it to load the .proto file. Okay, and then once this employee service object is created, we are using it to initialize a client for the Golang gRPC server we created in the earlier steps, right? So we are basically connecting to localhost 50051, and once we get the gRPC client, here you can see we are passing it to the get employee details method that is defined in a client .js, which is over here, right? And it basically has client, and it also accepts employee ID. So employee ID is basically like one or any command line arguments you pass, right? So whenever like this method will be called, the employee will be fetched and it will be logged to the console. Let us now run the Golang, the Node.js client. Okay, so yeah, you can see here that we are able to receive the a response from Golang gRPC server. So this is the first demo. Let me go back to the presentation. So our second demo is about storing protobufs file in Git submodules. Okay, so I had this demo in a separate branch, but due to some limitations of or like I mean due to the due to some limitations of Git modules, I had to like merge both of the changes in a single branch. Yeah, so you might have wonder that we need to like keep the reference for same proto file. So instead of like keeping two versions of .proto files, we can simply create a project, a Git repository where we can put all our .proto files and then just import that repository uh, in the projects where we are actually using them. So if you see here node grpc client, it is also using employee.proto. So I have added this employee.proto's repository as a sub module in node grpc client, and that we can confirm by having a look at this file. So git modules is basically is a file for like handling your sub modules in your parent repository, I would say. Yeah, so there is another repository called protobufs, so that I will also show you from here. uh, yeah, so this is the repository, and if I do ls here, then you can see employee.proto is only the file there. So package.json is just a metadata for that repository. Okay, so this this is like, I would say, the end of the second demo. Let's move towards the third demo, which is about running Golang gRPC server using server certificates. So we saw in slides that server can just have server certificates, and client can just access it. So it will not be mTLS, but just like server is having server side certificates. So to have this demo up and running, I need to basically introduce you another project called certificates, where basically I'm putting all the certificates related stuff. So let me check out the third demo branch of this project. I'm on third demo branch, and here you can see I have got gencert certs.sh and openssl config. Okay, so let me walk you through the gencert.sh. So here I'm basically creating root CA. Okay, then creating server CA, signing server CA using root CA. Okay, and then creating finally server certificates and signing them using server CA. Right, this CA. And then at the end, if you see here, then I'm also creating certificate chain that is basically required to reach to the server from client. Okay, so now let me also walk you through the openssl.cnf. So here are some constructs here, like v3 ca, v3 intermediate ca, and then server cert. So when I'm creating server cert, then that time I use configuration from this block. Okay, so one thing to notice here is that subject alternative names. Okay, here I can specify any set of alternative names, and also the extended key usage and few other things like key usage, you can have a look at them. Okay, let us now generate the certificate using this command. Okay, yeah, so it has created all the certificates, and if I refresh this now, yeah, here you can see certificate chain, root CA, server CA, and server certificates folder are created, and the proper files are inside them now. Let us move to Golang gRPC server again. So here we need to kill the earlier server's instance and need to check out the third demo branch. And then here, let me first compare the difference between the first branch and the current branch. Okay, so yeah, the change is basically in main.go only. And if you see here, so what I've done is that earlier we had started this grpc server, right? So there only so there I'm just passing grpc.creds and passing this creds object or creds structs basically, right? And the creds is coming from here, right? So creds is basically a new server tls from file, and these files are nothing but the grpc server cert and grpc server key, which we created in the certificates repository, right? And then I'm just using it to initialize the TLS configuration and starting my grpc server using creds. Okay, so that's the only change here. Let us now start the server again. Okay, my grpc server is up and running. Let me move to node grpc client. Okay, so what I will do is I will not change the branch and I will just try to hit the service. Okay, I should, yeah, I'm getting this error, right? Undefined. So I'm not able to retrieve the employee id. So let me now check out third demo one branch. And if you see here the undefined, we are just getting undefined, but we need to see the actual reason, actual error there. So this branch will tell you that one, because what I have done in this branch is I have just logged the error. So let me compare this branch with the earlier branch, and it just has one logger. If there is error, then it is just logging it to the console, right? So let me fire the node index.js again, and here now the message is printed. So connection is dropped. Okay, and uh, basically the client was not able to retrieve the information from server because the server is now configured with the server certificate. So in order to fix this, what we need to do is we need to add the chain server certificate chain uh, while calling the server, and that code goes in a node grpc client. So let me check out another branch called third demo 2, and let us now check what has been changed here, right? So comparing the branch with a third demo one. Okay, so the change goes in index.js. I'm skipping the readme.md changes because that's where I have just added few steps for my understanding. Okay, here you can see I'm loading fs module, file system module, and then just creating this object called grpc credentials create ssl. Okay, and it basically has the reference to grpc root ca and grpc server ca chain cert. Okay, and I'm passing this object to employee service. So earlier it was grpc credentials dot create insecure, right? But now we are using this credential object to create or to initialize to create a client of the Golang grpc server. And once we do this, let me now run again the node index.js. I should be able to retrieve the object, right? So now what is happening? Only the server certificates are in place. There is no TLS. There is no mTLS basically. Okay. Let us go to the fourth demo, that is enable Golang grpc server with mTLS settings. So what will happen now? I will block any connections uh, being made to the server if they are not gonna present the client certificates. Okay, so for that I need to go to the certificates first, because I am creating client certificates as well there for the grpc client, but not just using them, right? uh, yeah, so let us check what is modified now compare with the third demo. Okay, yeah, so there has been change in two files, jane-certs.sh and openssl conf. Okay, so in openssl conf you can see client cert block has been added now to create the client certificates basically. Okay, and in jane-certs.sh if you see I have added commands to create client ca as well as client certificates. So client certificates will be signed by client ca now, and also I have added one more chain certificate here that will basically be having grpc root ca, server ca as well as client ca. Okay, uh, now let's fire the jane-cert command again, because now it will create the whole set of certificates again, because that's what I have written in .sh file, but again you can configure as per your requirement. Okay, so it is deleting the earlier folders and creating new ones. Let us wait for it. uh, yeah, now we will go to Golang grpc server. I first need to check out the fourth demo branch. Okay, and now let us compare what has been changed, right? So uh, the third demo basically, right? Yeah, again there is only change in servers main.go, and you can see the package imported are crypto and some TLS and X509, right? Also there has been addition of cert chain as well as server cert and server key. Okay, uh, here if you see now I'm so basically I have refactored the code here as well. So earlier there was all the code was present in main.go itself, but now I have created some helper methods, so you can see many changes, but it is not the case if you look at the methods closely. So if you see get TLS config, right? So it is defined over here. It is just simply initializing the TLS config struct, right? And it is again using certificate. You can see here get certificate, I'm fetching it from the parent. Get certificate is another again method, and there also like you can see cert key and certificate. Like using cert and key, I'm initializing this certificate, basically loading the X509 key pair, right? And then returning the certificate that's in the form of this tls.certificate. And get cert full is something that I have added now, that basically like refers to your certificate chain. Okay, and it also adds your certificate chain your to your cert pool. Okay, and let me go to the top of it. Yeah, the same thing, server option is a new thing now, which is grpc.creds, and it accepts credentials.new tls and tc. Okay, so now what I'm gonna do is I'm gonna run this project first. Okay, so these are the only changes which we have done. Let me also see what is there. So just min.go changes. Yeah, I've started my server. Okay, and now I will go to node grpc client and we'll check out fourth demo, right? And let's do the same steps. Let's perform the same steps over here as well, comparing with the earlier branch. So third demo 2, that was the latest branch earlier, right? So in index.js you can see here now I have added a few things like read file sync, that is referring to the certificate chain, and then client certificates are being now used. So this node grpc client now it will also present the certificates uh, to the server. Okay, and then the communication will be made. So let me fire node index.js again. Yeah, I'm able to retrieve the employee again, right? Okay, let's move on to the fifth demo. So that is basically adding that is basically about adding a check to verify client certificates at server end. Okay, so what I'm doing is I'm gonna move to no Golang. Just before that I need to go to certificate. If I have fifth demo branch, I can also check from here. Oh yeah, I have. Yeah, I'm checking it out, and yeah, I'm on fifth demo branch, and let us compare what has been changed here. Comparing with the fourth demo branch, that there is a change in jainsert.sh, and the change is basically uh, yeah. So earlier this was the CN for client certificate. Now it has been changed to node grpc uh, client 3. Okay, so I'm not like I have just like checked out this branch, but I have not like run the .jainserts.sh file again. Before that, what I want to show you is let me move to Golang grpc server and then kill the earlier server, grpc server. Basically check out to the fifth branch. Okay, let me show you a few changes which I have made in this branch. With I'm comparing this branch with fourth demo. In main.go you will see few changes, and they are about like checking the certificate being received from the client. Okay, so this method is there, is invalid certificate. Okay, if the certificate is invalid, then I'm just uh, returning it from here. Okay, and is invalid certificate is basically do few checks, like it checks whether the from context is same, or like if there is auth info present or not. Again, the TLS auth state verified chains are equal to 0 or not. And if you see here, then I have one more check called common name. Okay, so the contains is basically defined over here, and it checks the valid clients are only these node grpc client 1, client 2, and client 3, right? And if you have noticed here in certificates, on fourth demo branch, uh, because these folders are still from fourth demo, right? I have not updated them yet. uh, Let me again compare it. So fourth demo, right? So earlier the name of clients, earlier the cn of client, it was this long, right? Like grpc node grpc client day 6 of, it was not node grpc client 3, because that's what has been changed in fifth demo, right? So let me go back to now node grpc server, and here if you see, the clients are valid only if they have these cns, right? Okay, now what I will do is I will run my server. Okay, node sorry, Golang grpc server. I'm gonna run it like this. Okay, and then I will go to node grpc client, and then from there I will run node index 3. Here you can see unauthenticated invalid subject common name unauthenticated client. Now, as I'm still using the earlier certificates, that means I don't have a valid certificate, right? And this client is not allowed to access the node, the Golang grpc servers method. That's why this message is coming. So let's fix that. How how to do that? So we need to basically run jane-certs.sh on certificates sh certificates repository, because there now we have cn called node grpc client 3, right? So once the certificates are created, we will kill the grpc server again. We really don't need to do that, but let us kill it and then again go to node grpc client. And I don't think that there is a fifth demo branch here because it is really not needed. Yeah, there is no fifth demo branch. So I will simply run node index js3, and yeah, we can now see the response because this client is now using the proper or I would say the selected common name, right, as a certificate, as a client certificate. Yeah, so that is end of the fifth demo. Let us go to sixth demo, but before that I want to explain you the setup, because I have already talked about this diagram. It has now just got some more content here. Yeah, so if you see, uh, there is a Kubernetes cluster. Okay, then there is a devsecops meetup namespace. Okay, namespace is a Kubernetes object, and there inside that namespace I have a grpc server Ingress. Okay, that is basically talking to service called Golang grpc server. Okay, and then this service is basically wrapper for my deployment. Okay, and deployment has pods and pod has containers, and my code Golang grpc server, it is running inside a container, right? So and also this deployment, this pod, right? So this basically refers to two CMs, config maps, basically Golang grpc config and employee database. So employee database is now like in the form of config map. Okay, that JSON I have put it in a config map format. And again this server refers secret. Okay, so why secret? Because the certificates which I have used, which I was using directly from the file system, I have now put them inside a secret because my server will now be running inside a Kubernetes cluster, right? So that's why the certificates in the secret. And also if you see here in the Ingress is also referring to another secret which also holds same set of certificates. Okay, just the keys are different. Okay, and then this Kubernetes cluster is installed with Ingress controller of Nginx. So Nginx Ingress controller is what I have installed, and that's what we will be configuring also. And then to this Nginx, my Node.js grpc client connects to. Okay, and so now there could have been two approaches to implement. I could have like unload the TLS related things at the Ingress level itself, and the communication from Ingress to pod that may happen over the plain grpc. But I don't want to do that. I want the TLS unloading at the pod level only. So my end-to-end communication will be secure. So from grpc client to grpc server, the whole communication will be uh, secure. Okay, there will not be TLS unloading on the Ingress level, and that's what was the main topic of this session. Okay, so this is with this understanding. Now let's look at uh, the sixth demo, deploying grpc server on Kubernetes behind Ingress. Okay, so just before that I want to show you I have got a cluster of so basically I have created this Kubernetes cluster using kind Kubernetes in Docker. Okay, and I have already installed Nginx Ingress controller on it. Okay, and here you can see there is no devsecops meetup namespace created as of it. So we will be creating them now. So what will happen is that a new namespace will be created here, and then we will be putting all the Kubernetes related objects in that namespace. So let us move first to certificates repository, and here I need to check out the sixth demo branch, right? And so let us see what changes have been there. Okay, so let me compare this branch, the current branch, with the earlier branch, that is fifth demo. Okay, so Jane cert has changes, and the changes would be, yeah, so the change is in server certificate, and here I'm changing basically the CN of server certificate. So earlier it was localhost, but now it is devsecops.kubedaily.com. Okay, this is a, like a entry in a /etc/host, but it needs it. Okay, so this is change in Jane certs, and in Jane, so I have added this new file called janesecrets.sh. So it is just having some set of kubectl commands. So I'm deleting name devsecops meetup namespace if it is already there, then creating a new one, and then creating some bunch of secrets, but with the certificates content. Okay, yeah, so grpc ingress server certificate and then grpc server certificate, these two secrets are needed, as I showed you in the diagram as well. Okay, then OpenSSL Cnf, it will just have some subject alt names for so this alt name is basically used inside the server cert block, right? Okay, so now what we need to do is uh, we need to fire janecerts.sh. Okay, then we need to also do janesecrets.sh. We also need to fire that command. Okay, jane secrets.sh. So it will, yeah, it has created namespace. Okay, then it has created 4 secrets. Okay, so only 2 we are using, but I had this script, so I think it is creating for all of them, but only 2 secrets we are basically using. Let's move now to Golang grpc server. So first we need to check out the 6th demo, right? And we also need to see, or I would say compare this branch with the 5th demo branch, and you would be seeing mainly the changes in Kubernetes directory. So that's a new directory I have added. Okay, and in server, yeah, I have added Docker file as well. Okay, let me first walk you through the Docker file. So it's simple Docker file for Golang based projects. Okay, so like using Golang 1.16.4 as a base image, then like copying Go code to to Docker work dir, and then again creating the so here creating the binary file, and then again just copying it to the uh, folder, and then finally running the Golang grpc server Golang code, right? And in main.go, so basically as I said that I have moved employees.json file to config base. So you can see here that now the okay, just before that, I need to walk you through these files, config map.yaml. So, so it's a config map is a like Kubernetes object, and here you can see I have one config map called Golang grpc config. It basically has the data, or like I would say, two keys, server address and server port. Okay, so Golang grpc server is my service, devsecops meetup is my namespace, and then the whole other path is there, right? And the other config map is employee database. It simply has employees key in it, and then it just has the JSON data, right? And then in deployment.yaml, so it's like a simple YAML, simple deployment YAML. We will directly go to the spec section and the another spec section of it, and here you can see the image which I'm using is Mahindra Bagul / Golang grpc dash server and latest. So I'm not going to push a new code to the Docker now. The same code is pushed and available in this Docker image. Okay, and also you can see the environment variable server in port, and then employees, which I'm basically like accessing from the config map, right? And again the port, container port is 50051. Okay, also you, one thing you need to notice is that I'm mounting the secrets as volumes. Okay, so this is a standard practice of using secrets inside pods. Okay, the ingress YAML, I would say this is like a the crucial configuration. Okay, because here you need to specify a few things, because you don't want to unload the TLS related things on the ingress level. So you need to you need to set the SSL pass through as a true. Okay, and the backend protocol is going to be grpcs. Again, auth TLS secret is devsecops meetup is the namespace, and grpc ingress server certificates is the secret name. Okay, and host, so this is the host, because that's why I also had to like configure it in the common name of server certificate. Okay, and then whenever the request will be coming to the slash, then the request will be passed to the Golang grpc server service. Okay, so service is another Kubernetes object defined here. So it's simply a wrapper, I would say, because it is wrapping the pods using labels. Okay, so 50051, that's the same port. Okay, it's a node port based service. Let us move now to main.go again. So as I had created employees as an environment variable in a in a pod spec, so that I can use here. I can just like convert it. So I will basically be having all the employees available as a byte array, and then I just need to unmarshal them using JSON's method, and then the all employees list will be available in this format. Okay, down below, yeah, few things are now changed because earlier the path was different for accessing certificates. Now the path is different because on /app/certs, that's where I have mounted the secret, and that's where the certificates will be available. So that's why that's why you will see the changes in the paths. Okay, so yeah, we are almost the done with seeing the changes. Let's now run. Oh, we cannot now run server /main.go because we are not gonna run this Golang server on our local machine. We are gonna uh, run the Golang grpc server on the Kubernetes. So as you can see here, yeah, I am in devsecops namespace, and there are no pods found, right? So let us do k apply -f Kubernetes slash. So all the resources defined under this directory will be now created. Okay, so I'm just firing this command, and you can see here two config maps, one deployment, one ingress, one service. They all have been created now. Okay, let us do kgp first. Yeah, here you can see there is a new pod getting ready. It's not in ready state 8. Okay, it's running, but it's not in ready state 8. Okay, we will also see the service. So kgs will give you the service. So Golang grpc service server is the service name we created. Let's access kgi Kubernetes kubectl get ingress, and you have grpc server ingress also, and the host name is this. Okay, and yeah, so that's pretty much, and we don't need to see the secrets because we have already seen them. uh, let's let me do kgp once again because I need to see whether my grpc server is up or running, is ready to accept the traffic. Yeah, we can see one on one. That means this server is ready now. This server is ready now and can now accept the traffic. So we don't need to start server here because we have already started it in a Kubernetes cluster. Let's move to grpc client. uh, so we also need to check here the 6 demo branch because I have done some specific changes here. Not much, just one or two. Let me compare the current branch with the earlier branch. That's fourth demo because this project doesn't have fifth demo branch. And in index.js, you can see I have just updated the URL. Localhost has now become devsecops kubedaily.com, and the port is 443. So you might be wondering that the service and the pod uh, they were running on port 50051, but the thing is that KGI, that is uh, kubectl gate ingress, that is running on port 443, and 443 is because we are using grpcs and into an mTLS connection. That's why, right? So let me do node index 3. Yeah, we are now able to access the details from the server which is running on Kubernetes. So that was the sixth demo. Let me move to the next part of it, presentation. Yeah, so I think I'm done with my presentation. And yes, we are hiring at InfraCloud. You can visit this link for the opportunities available as of today. Okay, or you can just send your resumes at this email ID, careers@infracloud.io. Thank you so much. Bye everyone.